Hey everybody, this is Austin and welcome back to the channel. Let's talk about joints in Fusion 360. While normally I have high praise for just about everything in Fusion, I hate joints. It's one of my least favorite parts of the Fusion 360 toolkit. And don't get me wrong, I use them all the time and they are super important when dealing with assemblies. But the way Fusion designed the joint system makes it seem like they tried to come up with something very easy and intuitive, but in practice, it ended up being quite messy and confusing, and you feel like you have to work around it more often than it actually works with you. So the joint system is actually especially confusing for those of us coming from SolidWorks who are used to the mate system, which to this day is the gold standard in my opinion. But since most of us use Fusion, it's going to be necessary for us to get a handle on joints. So today we're going to explore what a joint is, the types available and how they work, and what are some of the best practices when dealing with joints to make them much more enjoyable. So you know the drill, let's not waste any more time and dig right in. Okay, so let's quickly cover the fundamentals of joints so that way we understand what we're trying to accomplish before we dive into all the settings, how joints work, or what types of joints there are, etc. So a joint is effectively a constraint for components. Now, if you're familiar with constraints on 2D sketching, for example, then let's say I have a line here. I can take an arc, and let's say I need to connect that arc to that line. So I can select both of those points and make them coincident. And I could say I want that arc to be tangent to that line, and maybe I want to make this a 2-inch radius. That is effectively a joint, but it's on 2D geometry rather than 3D geometry. And so what we are actually trying to do is connect various geometry of our modeled components together, just like we would do with a 2D sketch. So for example, I want to connect this face to that face, right? Or I want to connect this cylinder to that inner diameter. So what I can do is I can say I want to connect that face, hold Control, and click that face, and then come up to here and either hit the joint button, assemble joint, or hit J on your keyboard, which is my favorite way of doing this. So I'll just hit J, and Fusion will do its best, although there is a reason, there is a method to the madness of how Fusion decides where to put items, and which we'll go into in a minute. But Fusion will try to lock that component to the other component with the information you gave it. So for example, right now I can move this component, and right now I can move this component. They're two separate entities. But if I select that face, select that, hit J, and hit OK, now those two move together. And I can do the same thing with a cylinder. So I can select that and this, hit J on my keyboard, hit OK, and those will now move as one piece. However, you will notice that, for example, this didn't line up in the center or, that ring to that ring or anything because we gave Fusion too little information. We need to give it a better set of instructions. And in order to understand why Fusion aligned this ring to this cylinder, for example, in that fashion, we actually need to take a step back and understand how components work, because I think that will clear up a lot of the confusion around joints in Fusion 360. So in order to understand components, we actually need to understand the design tree a little bit, because that will really help explain how these components interact with each other when applying joints. So anytime you open up a new design, you have the top level part of your tree, but you'll notice that it's actually a component. We have one component already provided for us in our model, and all that is in it is an origin point. And this is a fixed component. This component cannot move. Anything that is designed directly under this component cannot move, which we'll talk about in a second. But that origin point is one fixed or known spot on the model, so that way Fusion knows what to do with all the other components. So anytime you create a new component, you'll notice that what you're actually doing is creating a new origin point. So if I highlight the origin point at the top of our model is right here. This is the one that can't move. But now that I've created a new component called corner, that origin can move along with that component. And so what can often happen, which confuses a lot of people when you try to say join this to this, we didn't really provide Fusion a lot of information on how we wanted those to relate to each other. So if I actually open these up and I show their origin points, we have this one, and all we said was this face to this face. If I hit J, Fusion doesn't know what to do with it, so all it simply does is aligns their origin points together. And that's why this ring, for example, didn't align, let's say, to the top or exactly in the middle between this face and this face, etc. Because we didn't give it enough instructions, so Fusion decided to align their origin points. And so that's really important to remember, because also when you sketch on this top level component, that origin point is fixed. So if I created a body, just a top level body right here, I can't move that anywhere. And that's because it's drawn in relation to this origin point. It's not drawn in relation to a separate origin point that we would have given it if we created it as a new component. So that's why top level bodies cannot move, and it's almost always a good idea to, whenever you create a new design, the first thing you do is hit create new component, because that way later on you'll be able to move that item somewhere else when you've created other geometry. But it can also be useful sometimes to have a top level body that is fixed and can't move anywhere, so that way it makes joining everything else to it much easier. So let's say, for example, all of these components that we created are intended to be joined to this cylinder. Now, they're not really the right shape for that right now, but that would mean that I could join, let's say, this to this, and then hit OK, and now it can no longer move because the base body that it's connected to cannot move. So even though these two, when they were connected, I could move both of them together, for example, this one can no longer move because it's actually joined to a body that is fixed. And that can actually be a pretty useful way of creating an assembly. But there's also another and often better way to do that, which is to ground an item. So for example, if we didn't have a top level body and we just created components, what we could do is a couple different methods. We could right click and hit ground. And effectively what that does is it fixes that component in place and it adds that to your timeline. And so now wherever this origin point happens to be in relation to this one, it is now fixed and can no longer move. And then that way, let's say we wanted to join these two together again, and I hit OK. Now I can no longer move them because that bracket on the back is fixed in place. So that's a very good way to lock down your model to not let it get too unruly when you have a lot of components. Another way to do it is to actually simply join the origins together. And this is actually one of my favorite methods. So what I'll do, for example, is I'll come into my design tree and I'll say this origin point and this origin point. So I selected these two, hit J, and I'll just join those together. So that way the base component that I want to join everything else to, even though I have it as its own component rather than a top level body, is aligned with the origin point of the model. And that way everything is centered and my camera rotates around that pivot point. And so that can be a really good way to do that. So with that out of the way, we kind of now have an understanding that when we join components together, if we don't provide it a lot of information, then what Fusion will do is align the origin points. And sometimes that can give you undesirable results. But if we give it the proper information, then what we can go ahead and do is join everything the way we expect. So let's say this ring to this ring, hit J, hit OK, and now those two are locked together. But maybe we didn't want these to be rigidly connected together. Maybe we wanted some rotation available to it. So for example, if this was a bushing and this was a cylinder, then maybe we wanted this bushing to be able to rotate around this body. And that's where the second half of joints comes into play, because rather than just rigidly connecting via the origin point or letting Fusion decide where we want it to go, we can give it a better set of instructions and we can actually open up freedom of movement in one or sometimes multiple axes. So let's go ahead and talk about the different types of joints and how to apply them. So let's go ahead and start with this cube right here, because we've already talked about how to, let's say, select those two faces and hit J and let Fusion decide, but maybe we want to elaborate a little bit on how those are supposed to be connected. So something I unfortunately didn't show you earlier is when you just select these two and hit J, Fusion automatically assumes you want to do those. But what you can do is if you hit joint first before selecting your geometry and you hover your mouse over, you can pick which point and which axis of that point you're trying to join that to. So for example, if I wanted to achieve the same thing, I could say the center point of this face to the center point of that face. And that's effectively what Fusion was trying to do earlier, or assuming. But maybe that's not what I actually wanted. Maybe I wanted this corner to be aligned with that corner, and I wanted to join it in that fashion. Or maybe I wanted that corner, but on this axis, to be aligned to that corner on that axis. And you'll notice that Fusion had to rotate in order to accommodate that. And so effectively what it did is we were picking which part of the origin point of this model do we want to align to the origin point of this model. But that is a basic rigid connection. You can pick which part of the model you want to connect to each one. Now, what we can do is once those are connected, so let's say the center point here and the center point here. Well, Fusion, since these two faces are coplanar to each other, Fusion can only rotate this model in one direction. So there is a rotating wheel here. So if I didn't want them to be coplanar, or the other faces to be coplanar, I could say I want those to be joined that way. Now that really wouldn't make sense in this type of a model, but not only can I do that, I can also say an offset from that face. So I want those to be joined, but I want that to be, let's say, 3 inches off, so that way it roughly lines up with the outside there. And I could do it that way too. And so now those two are fixed together in that position. So if we undo that, what I can also do, so let's go back and I want to say, let's say the center point here to the center point here. What I can also do is I can flip that orientation. So if Fusion guessed wrong on which orientation of that face you want to be connected, you can come down here and hit flip, and it will flip it to the other side of the joint. That is immensely helpful because that once you get into more complicated models, that is very common, and you'll often find yourself flipping your joint 90% of the time. So on this tab, there's also a couple different options. So there's between two faces, and there's also two edge intersection. So let's cover two edge intersection first because that's more relevant to the cube. So what two edge intersection does is I can say I want the intersection of this edge and this edge, which happens to be that point, but that's not always the case on other models, to align, let's say, to the center point of this face. So it's taking the intersection of that edge and the intersection of this edge and aligning it to the point that we selected on that face. So I could say I want it to align to this face, and it will move it to that location. That's basically how two-edge intersection works, but it can be very useful on more complicated models. So now let's talk about between two faces, which in my opinion is one of the most powerful joints that exists in Fusion, and one that was sorely missing from Fusion for quite a few years until they added it in, but they only added it in under a right-click menu. But thankfully, Fusion listened and they finally placed it in the actual joint menu. Now, in SolidWorks, for example, this was an incredibly powerful tool under advanced mates, and it was called the width mate, which allows you to select 4 faces and have 2 of those faces be exactly in the center of the other 2 faces. So let me show you how this works. This is a way where we can guarantee that this, let's say, bushing will be exactly in the center of this model, even if we change the dimensions of this cylinder, for example. So we can say between 2 faces, and we can say this face and this face of this component. And where do we want the snap point of that to be? Well, I can just highlight over this, or I can come here, hit here at the bottom, but we can just say the outer point of that, which will align it with the center point of that model. And then I can say between two faces on the other model, and I can say this face and this face and do the same thing. And what it's going to do is it's going to analyze your models and make the distance from this face to this face the same as the distance from this face to that face along that center axis. And that is an incredibly powerful way, for example, of lining up, let's say, screws or shafts into that are meant to rotate, and there's clearance between them and everything, and you want them to be able to move and slide and rotate. So now that brings us to the second tab up here on the top, which is called Motion. And this allows us to add or remove certain degrees of freedom of movement from the joint we just created. Now, this is the biggest difference between mates in SolidWorks versus joints in Fusion. Now, mates in SolidWorks, for example, what they do is it's an additive system. So you start with no constraints and you constrain each axis of that part one by one until only the freedom of movement that you want is left available to the part. And if you wanted to fully lock it down, then you would also add a constraint to that axis as well, or a mate rather. But in Fusion, what Fusion tries to do, which can be infuriating sometimes, but is also sometimes elegant, is it tries to automatically do all of that all at once. So right now, because we did the between two faces, right now it is a rigid joint that's automatically locked down, and we did that with what would be one mate in SolidWorks, but we did that, that would be three mates in SolidWorks, but we did it with one joint in Fusion. And instead of adding additional joints in order to constrain each axis, we can just remove one freedom of movement or sometimes two. So for example, maybe we wanted this to be able to rotate inside of this bushing. So I could select Revolve, and that would allow it to revolve in whichever axis we choose. So if I chose X-axis, which makes 0 sense in this case, or Y-axis, which is the same thing, or Z, which allows it to rotate. Now there's also custom, which you don't use very often, but sometimes you need it to revolve, diagonally or something. So that's an easy one. And then we can also go to slider, which allows this to slide up and down. So let me go and hit OK real quick, because even though these two are aligned, the distance between these two faces are the same on both sides. Because we've added a sliding mate, I can move that model out of that position. And what is the point of this? And the point of this is because that is a temporary state, where if I come back to this little highlighted section right here and I double click it, I can hit 0 and it will always go back to the default rigid position. But that would allow me to move my model up and down so I can see how everything is going to interact. And then when I need to bring it back to its standard position, I can just come back here, hit 0, and come back, and everything will be back where we expect it to be. So let me open up that joint again. And then we have cylindrical, which is 2 axes actually. So not only is it rotating in the Z-axis, it's also moving up and down in the Z-axis. So it's kind of a revolute and a slider combined into one. So if I animate that again, I could say Y-axis and it's going to do the same thing, or I could say, I said X-axis or Y-axis. So if I say the Z, it's going to revolve and move up and down at the same time. So if I bring this up, it allows freedom of movement in both of those axes. Now if I come back to edit joint, let's just keep going through these. There's also pin slot. It would allow freedom of movement in 2 axes as well, and you can define each axis separately, whereas in cylindrical, it's kind of assumed, but in pin slot, you can say which axis is the rotation and which axis is the slide. So I could say I want it to rotate in the Y-axis, but I want it to slide in the Z-axis, right? Or I wanted it to rotate or slide in the X-axis and rotate in the Y-axis. So that's a really interesting one that I could see being useful for certain gears or certain things like that. So then you also have the planar, which allows the model to move in 2 axes and also rotate in a different axis. So let's play that again. So you can see the model can rotate, but it's also moving between 2 axes. So if my normal axis is Z and my slide is X, then it's automatically going to assume that it's going to move between these two axes. So I could say, let's move this to Y, and that allows it to move in Z. So you can see from this angle, let's reanimate that. It is moving, it's rotating around in Y, but it's also rotating this way and going up and down. Now, that's a pretty hard joint to get wrapped around, and in this case, it makes 0 sense, but on certain applications, it'll make more. Then you also have ball, and basically ball is 3-axis movement, right? So it's like a ball joint for a camera. That would be a perfect use case scenario for this type of a joint where you've got a ball joint and you need it to be able to move in all 3 axes depending on how you grab it, but being located around a central point. So I apologize if I didn't explain the last couple very well because I've honestly never really had a good opportunity to use them. So I was kind of winging it a little bit, but I have played around with them enough to roughly understand what they do, but not necessarily the applications they should be applied to. So if I got some of those majorly wrong, please let me know in the comments and I apologize about that. But let's actually move on to a real model where we're going to do a relatively quick assembly and use some of these techniques that we've applied. Okay, so here's a prototype Z Axis that I was building quite a while ago for a machine that I was going to build. I never finished it. I don't have ball screws or the top plates or anything like that. But this is going to be a pretty good use case that will show quite a bit of the techniques we just went over on how to use joints for assemblies. So what I'm actually going to do, you can see right here that it slides. I'm just going to delete all of these joints except for the rigid group at the top. So now everything's kind of flipped over the wrong direction and we're going to have to realign and get everything back into place. So this is going to be a pretty good use case. So let's go ahead and assemble this back plate first to these bearing blocks. So let's go ahead and do that. Bring it into position roughly so that way we can see everything a little bit better. Okay, now let's go ahead and join these. So what I'm going to do is I'm going to say I want this ring right here to go to that ring right there. Really simple, make sure it's a rigid joint. Yep, now it can't move and it's moving along with this plate. So we're gonna do the same thing on the other side. And we're gonna say that ring to there. Hit OK, rigid joint, done. Now you'll notice that these two are actually flipped backwards. So this is gonna be really interesting because we're gonna have to reorient this a little bit. So this face should be facing this face. So what we actually want to do is select this ring right here and connect it to that ring. And you'll notice that it's going to orient incorrectly. So we need to flip that orientation, but you'll notice it's still not quite right because the grease valve should be facing the outside. So I'm going to rotate that model into that correct orientation. And now that's in the correct place. So we can go ahead and be done with that one. And we're going to have to do the same thing to this side. So we're going to say this one right here to that one right there. These are just the screw holes that these would mount to. And I need to flip that orientation. And then I need to rotate it into place. Make sure it snaps to 90 degrees. And we're good to go. So that plate right there is kind of already assembled. Okay, so now we need to get these rails attached to this plate. And unfortunately, I didn't actually include the mounting holes because I never really got that far. So what we're going to do is we're going to just select this face. And we're going to select this face and hit J and see what happens. And in this case, that works out because they are already the same length. Now, if they weren't the same length, you might be able to do between two faces. So like a between two faces between this face, that one, this face, and that one, etc. Or you might be able to create your mounting holes and do it just like we did with the bearings on the back. In this case, it actually works pretty easily. So we're just going to hit OK. And then on this one, we want to also mount this face to this face. And that's going to go ahead and line up for us, and we're good there. So now that we got that kind of pre-assembly done, what we're going to go ahead and do is we're going to mount these bearing blocks to this, but you'll notice everything's kind of facing the wrong direction. So what I'm actually going to go ahead and do is I'm going to take the origin of this and join it to the origin of our top level assembly, which is right there. So I'm going to click on that plate, find that component, open up that origin, and I want to click on that origin and join it to this origin. Hit J, just make it a rigid joint, and hit OK. Now this is locked down, so that way nothing gets rotated around by accident later on because now we've got so many moving components. And then I'm going to hide that origin. And let's mount these bearing blocks. So I'm going to look at it from this direction. Put these roughly in place. Look at this direction. We'll do it right about there. Okay. So now we're going to actually do the between two faces like I showed you and how you can utilize those pivot points. So if I hit J on my keyboard, I'm going to say I want to join between this face and this face. Oh, I didn't actually select between two faces. I want to select between this face and this face. And I want also between two faces, pivot point. We're going to click on this face right here, if I can get it. And then we're going to select between two faces on this. We're going to select this one right here, the bottom, and then the pivot or snap is going to be right there. Now you'll notice that automatically snapped into position. Now if it showed up like this, all I would need to do is just hit the flip button. And if I hit OK, right now it's a rigid joint, but I actually want these to slide. So I'm going to go into slider, make sure, yes, it's moving in the correct direction, hit OK. And now these blocks can move up and down here. And now we're going to do the same thing to this side. So I'm going to hit J between two faces, this face and this face. And then the pivot will be this face right here. And we'll do between two faces up here as well. That part, and then the snap will be that center circle. Yes, it aligned correctly, hit OK. And we can, that is rigid joint, so we need to actually go back, edit, go to motion, hit slider. Now it can move appropriately, and we're in business. So now these two can rotate, or not rotate, slide appropriately. So now we need to go ahead and connect this plate to those right there. And so that way these will move in sync with each other all the time. So what I'm going to do, let's look which side is the front. So this is the side that's going to be the front. So we need to mount this back plate to it. So I'm actually going to select this one right here, and I'm going to connect it to this top right one right here. Now I need to flip that orientation, and I need to rotate it into position. Make sure it's set to 180. Yes, we're good there. Okay, so now those two are moving together, and because we just did a rigid joint, we didn't have to do a slide joint on this plate because it's attached to a part that already has a slide joint applied. And so now all we need to do, this one's going to be a lot easier. All we need to do is attach this right here to this one right here. Make it a rigid joint. Go away. There we go. Make sure it's rigid. Yep, we're good. Okay, so now this whole plate moves up and down accordingly. So now we've got our rails and our bearings and our plates kind of established. All we really have left to do is go ahead and get the spindle mount on, throw in the spindle, and then we can be done with it. So let's go ahead and mount this one because we already know this is kind of backwards. We're going to mount this one to this one right here. It's in the wrong orientation, so we're going to flip it. Now it's already in the correct orientation. So we can just hit OK. And remember, everything is still sliding together because these are all rigidly connected to a part that has a sliding joint. And now we just want to go ahead and add our spindle. So I can say spindle, we're going to join it from here to this ring. And let's hit OK for now. Now that's assuming that I wanted to mount it all the way down, but maybe I don't want to do that. So maybe I want to make sure that there is 1.5 inches below the mounting ring. So negative 1.5, like that. Maybe I wanted to mount it like that, and that'd be fine. And then I also have a little bit right here that I threw in there for detail. So let's go ahead and let's mount this one right here to this right here. Now that's sticking out too long, so we need to actually say we want the bit to be inserted into this, let's say 1.5 inches. And now we've that quickly gotten this whole thing assembled to where it can slide. Now, what would happen is I would then save this as its own file and then insert it into my larger CNC assembly file in which I could then mount these blocks to the rails of my gantry, and I could make that a sliding joint so it could slide side to side rather than just up. But the Z-axis only travels in one axis, so that's the only motion joint we needed. But this was a really quick example of how you can use joints to assemble and bring your model together and get the functionality you want out of it. So hopefully that clears up some of the confusion around joints in Fusion 360. Now, I remember when I started using Fusion 5 or 6 years ago, the joints tool was much less developed than it was today. And I remember coming straight out of SolidWorks, it was infuriating and almost made me want to drop Fusion altogether. However, they have made a lot of improvements over the years, and I now find it much less frustrating to use than I used to. There are a lot more advanced techniques for overcoming troublesome joints that I really couldn't get into today. So if you guys would like to see more on joints, maybe on specific models or something like that, let me know down in the comments and I would be happy to do that. If you'd like to support this channel and help me to continue making Fusion 360 tutorials, you can find me on patreon.com/Austin Shaner. If you'd like to join a growing community of designers, engineers, luthiers, and hobbyists from all over the world, you should join our Discord server. Links will be in the description below. But that's all I've got for this video. I'll see you guys in the next one. This is Austin, signing out.